Today we're going to be looking at something called the problem of induction. Now what we're looking for here is knowledge, true, certain knowledge. And in order to get to this goal, I'm going to try to present this problem in a very impartial and unbiased manner. One more admonition before we get started. This is a basic introduction to the problem of induction. If you want something more rigorous or challenging, check out the problem of induction on the Stanford Encyclopedia of Philosophy. Generally a good place to start most philosophical investigations. You could also check out, for a new twist, The New Riddle of Induction by Nelson Goodman, and I would be remiss if I did not mention An Inquiry Concerning Human Understanding by David Hume. With that out of the way, let's get started. First, we're going to look at our project here at Carneades.org, which is to doubt principles and test some of our most closely held beliefs. The belief that we're testing today is the belief that science can guarantee knowledge, true, infallible knowledge. Can we know things that are proven by science? And do they stand up to our high bar for knowledge? Well, let's see. Now, who's this a problem for? This is a problem for people who believe in induction. Induction is the idea that if you have a bunch of specific claims, you can, from those claims, draw a conclusion about something more general or about the future. Let's take a look at what that looks like in terms of the scientific method. If you do experiment X and get result Y once, you do experiment X and get result Y over and over and over and over and over and over and over again, eventually you should be able to conclude that experiment X will give you, or will always give you, result Y. Let's take a look at something more concrete. Imagine we have an urn we can't see into. We reach into this urn and we pull out a black ball. We reach into the urn again and we pull out another black ball. We reach into the urn a third time and we pull out a black ball. We want to, from this, make a conclusion. We can draw the strong conclusion that the next ball will be black. We can also draw a weaker conclusion that it's likely that the next ball will be black. Today, in this video, we're going to deal with the strong conclusion, and later we're going to check out the weak conclusion in another video. To support the strong claim, we have that all the balls so far have been black, and we want to conclude that the next ball will be black. In order to do this, we have to go from the past to the future. In order to have a valid argument means that true premises will guarantee a true conclusion, we need to have something along the lines of the future will resemble the past. Well, what support can be provided for that claim? Let's see. We want to conclude that the future will resemble the past. So far, the future so far has resembled the past. If you want to think about this in terms of the balls, after we drew out the first black ball, the next one resembled it, and the next one after that. The future, from that point of view, resembled the past, the ball we had already pulled out. That's a claim about what's already happened. What we want to conclude is a claim about what's going to happen in the future, that the future will resemble the past. The problem is, to get this argument working and off the ground, once again, we need a bridge from the past to the future, and the only thing we can do that is a version of the future will resemble the past. Uh-oh. That looks like begging the question, because one of our premises is our conclusion, and that is a fallacy. It's a logical fallacy, and it doesn't work for arguments. Let's see why. Imagine I wanted to conclude that Carneades.org is the best website ever. I might have as a premise, Carneades.org is the best website ever. Technically, this is a valid argument. If the premise is true, the conclusion has to be true, because they're the same statement. But it's only trivially valid, and it's not going to convince anyone. Now, this, I believe, can tell us we can cross out that strong claim, the next ball will be black. In fact, there was a chance, looking at the bottom of that urn, that the next ball would be red. So it wasn't a good claim to begin with anyway. Let's take a look at how this claim will apply to something that's a little more scientific in nature. Think about a sunrise. The strong claim here is that the sun will rise tomorrow. The weak claim is that it's likely that the sun will rise tomorrow. Now, to support the strong claim, we have the fact that the sun has risen every day till now. And our conclusion wants to be, the sun will rise tomorrow. The problem is, once again, we're going from the past to the future, and the only way we know to do that is through some version of the future will resemble the past. But unfortunately, the only way we can support the future will resemble the past is through circular logic. This means it's a no-go. So, some final conclusions. If someone gives you a strong claim about science, something that says that science can tell you something that is 100% undeniably true, I would argue you should suspend judgment. In terms of the weak claim that things could be probable based on science, well, we'll take a look in the next video. So stay tuned. If you have any scientific claims that you believe can stand up to this argument, submit them at carneades.org. Stay skeptical, everyone.